Okay, so here we go again. When we're talking about something like this, it's really the same thing. Remember, we take the base, we raise it to this over here. It says 1/2 squared is equal to x. The argument is equal to 1/4. Okay, so we're just saying we can have that situation pop up there. Now, when we're talking about up here at the top, remember we're saying, okay, if we have the natural log, or we have the log of base 10 of x, log base 10 of 10, this x over here, because it's an exponent, can do what? Travel over to the front. So what would we get? X log base 10 of 10. But what is log base 10 of 10? 1. So the whole answer would be x, right? So they're just showing you some of the tricks that we're going to run up against, because now we're starting into just a little bit more complicated log problem. So we have 10 to the negative 2x plus 2 is equal to 8. All right, now we've got a 10 on one side, but on the other side we have an 8. So what can we do here? We could take the log base 10 of both sides, but remember the log base 10 on this side is going to work, and log base 10 on this side, we're going to have to go to the calculator because we can find the log base 10. But if we take the log base 10, which is the common log of both sides, then we get log base 10 of 8. So we have to go to our calculator. What is log base 10 of 8? That's just your regular log key. So if somebody hit the log key and get the 8, then this one's going to do what? It's going to be a log base 10 of 10 raised to a power. That power is going to run around to the front, and we're going to take this whole thing, run it around to the front, negative 2x plus 2, and then this is behind it, and it is 1. And then over here, what is log base 10 of 8?
0.903.
0.903. Okay, so now I've got this, and I don't need the exponents, I mean the parentheses anymore. Can I take a 2 away from both sides? And I get negative 2x, I subtract 2, I subtract 2. What's 0.903 minus 2?
Negative 1.096.
Negative 1.096, and then I divide both sides by negative 2, and what do I get?
0.548.
0.548. And that is correct. Okay, 0.548 is the answer. So we're now using logarithms to what? Separate the exponents out so that we can solve. See, our variable is in the exponent. So we are using the logarithm to separate that exponent because of that runaround property. It runs around to the front when we are able, trying to get not so much light on my board here. Okay, so now let's look at this one. E to the negative 2x plus 3 equals 5. So again, we have our exponent has our variable in it. So we've got to separate this e from the x. And the only way to do that is to do what? We're going to do what? Take a log or a natural log maybe? It's still a log, but we're going to take a log base e, right? Natural log, and on the other side, natural log. Whatever we do to the left, we got to do to the right. Now, because it's a log, this is going to run around to the front. We get negative 2x plus 3. Natural log of e is natural log of 5. This one goes to 1, right? So now we have negative 2x plus 3 equals. What is natural log of 5 on the calculator? Somebody hit the LN key and click out natural log of 5, please.
1.609.
1.679?
09.
09. Is that right?
Yes, ma'am.
Okay, so now keep it on the calculator because now we have to subtract 3 from both sides. So what's 1.609 minus 3?
Negative 1.391.
Is that correct? Now divide both sides by 2. Negative 2.
0.9 or 0.695.
0.695. Okay, and x is going to be equal to 0.695. All right, so as long as we are dealing with these and we use either a natural log or a common log, we're able to take the log of both sides and we're able to click them out using the calculator. Okay, now on this one, neither one of these sides is going to go out nicely. We're going to have to use the calculator on both of those sides. Now, if they had been nicely raised to having the same base, it would have been easy, right? Because we could have gotten rid of it. But since we can't, we're stuck with this. We're going to take just a log of both sides. So when I take the log of this side and I take the log of this side, then I'm going to run this around to the front. 2x minus 1 times log of 5 is equal to x minus 2 times log of 6. So who can give me log of 5?
0.699.
0.699. And who can give me log of 6?
0.778.
Okay, so now when I distribute, I'm going to get 0.699 times 2. Somebody give me that.
1.398.
Minus 0.699 is equal to 0.778 x minus twice that.
1.556.
1.556. All right, so now we're going to try to get our x's together. And if I subtract a 0.778x and I subtract a 0.778x, what do I have left in the way of x's?
0.62.
0.62x. And then if I add a 0.699 over here and add a 0.699, that's really a subtraction, isn't it? Because I've got a negative and a positive. So that's going to be a negative
0.857.
0.857. So then I'm going to take my negative 0.857 and divide it by a 0.62.
Negative 1.383.
And x should be equal to negative 1.383, and it is. Okay, so does everybody see how easy those are? They're tedious because you have to go to the calculator for every one, okay? But they're not really that difficult. So that is lesson 82. Are there any questions on lesson 82? Any questions at all on lesson 82?
Thanks.